Hello everybody, today we're going to be taking a look at solving some radical equations. So solving equations that have radical signs in them and isolating that x. For this we're going to need all of our knowledge that we've been working on up to this point, your notes, some kind of calculator, and of course something to write with. So let's go ahead and get started. What you should remember about solving equations, it involves getting the x alone. So we're going to be working on isolating the x variable. We're going to use inverse operations to make that happen. So I may have to add if the problem has a subtract. I'm thinking about multiplying or dividing, square rooting or squaring, cubing or cube rooting, and reciprocal fractions. So we're going to be looking at doing whatever we need to do to undo the operation, so to isolate the x, and in the end we need to check our work and make sure that we're checking our solutions. So here is our first example we're going to write in our notes. We need to work on isolating the x here. Notice where the x is. He's inside of a cube root symbol. So we're going to need to work on all the steps here to isolate that x to get him alone. So to do that, let's first start with something that we see that's pretty simple to move away from the x. So I see this plus 7 in the back. I need to go ahead and get rid of that, or use the inverse operations to help start getting my x alone. So I'm going to subtract 7, subtract 7. 11 minus 7 is 4. I'd have 2 cube roots of the quantity x minus 3. Now I can't get inside there to add the 3 because that 3 and the x are both trapped inside the cube root sign, so not yet. But I notice that there's a 2 in front of the cube root sign. What is that 2 doing with the cube root? Well, it's multiplying because there is no other operation there. So we go ahead and we divide now by 2. And I'd have the cube root of an x minus 3 equals 4 divided by 2 is 2. Now to get inside there, to get at that x, we need to get rid of this cube root symbol. Okay, so the radical. How do we do that? Well, the opposite of cube rooting would be cubing. So we're going to go ahead and cube both sides of the equation. By doing that, I make 8 over here. That's 2 to the third power. And the cube root and the cube are inverse operations of each other. So I'm left with just the x minus 3. And now I can go ahead and add the 3, and I find that x equals 11. And we could check our work by plugging it back into the original equation. 2 cube roots of 11 minus 3 plus a 7 has to equal 11. So if I start on the inside right here, cube root of the 11 minus 3 is 8. So I have 2 cube roots of 8 plus 7 has to make 11. Cube root of 8 is 2, so this is like 2 times 2 plus 7 has to make 11. 2 times 2 is 4 plus 7 has to make 11, and that checks out. 4 plus 7 does make 11, so my solution is good. I can always check to make sure that my solution works in the original problem. That way I'm sure that I solved it correctly. Okay, let's take a look at a second example here. We have cube root of 2x plus 3 equals cube root of x minus 1. Now I'm not seeing anything that looks easy to move or easy to get rid of. And because of that, I think I need to do something first that would free up these terms. Because both sides are in cube roots, to get at those x's, we first need to get rid of those cube roots, or to undo that. So basically, we're going to take a 3 power to both sides, okay? Cube both sides. And by doing that, cube root and cube cancel out, and I'd have x minus 1, cube root of something cubed, and I'd have 2x plus 3. And so now I'm back into Algebra 1 land here, and I can go ahead and isolate my x. I'm going to move these x's over here to be with those. Minus 1, 2x minus 1x is 1x plus 3. Go ahead and subtracting the 3. And we'd have x, 1x, equals negative 4. So we can go ahead and test this in our original equation again, see if it works out. So far we have our solution is x equals negative 4. And if I plug it in, 2 times negative 4 plus 3 on one side, cube root of negative 4 minus 1 on the other side, Compute this underneath here. 2 times negative 4 is negative 8. Plus 3 more makes negative 5. I have the cube root of negative 5 equals, on the other side, I also have cube root of negative 5. Yay, it checks out. Both sides are in fact equal. Therefore, my solution is correct. I solved it correctly. Okay, last one. Third example. So we're going to go ahead and try to isolate the x here. The problem is we have x's here and here, and normally we want to bring those guys together on one side of the equal sign so that we can just have x in one place. But I can't move these x's over there. I can't subtract 7x because right now they're inside this beautiful square root sign. So I need to do something here to free up those terms, similar to what we did on the last one. Well, if I need to do that, what kind of root is this? This is a square root. And to do that, to free up the 7x plus 15, I'd need to square both sides of the equation. Now when I square something that's square rooted, yay, inverse operations, 7x plus 15 is what I have. When I square this other side, be careful, x plus 1 squared is x plus 1 times x plus 1. There's two of those things, okay? And then we distribute x squared, 1x, another 1x, and 1. So this side of the equal sign becomes x squared plus 2x plus 1. And the other side is still 7x plus 15. Well, now that everybody's out of their radical here, and we have some x's we can try to solve for, I think I want to bring these x's and constants over to hang out on the same side. Remember, when we have an x squared term and an x term, there's a pretty good chance we have to factor in order to be able to solve this guy. So we're going to bring these terms over there to hang out with the rest so I can see what I'm looking at here. So I'm going to subtract 7x, and I'm also going to subtract the 15. So I have a 0 over here, x squared, negative 5x, and negative 14. So what I see now is I have an x squared in my problem, which is telling me I should have two solutions to this. And to get those two solutions, factoring is a good tool. We could complete the square. We could use the quadratic formula. We have options. I think factoring is pretty fast, so I'm going to go ahead and do that. This would be a situation where we have the AC method. 1 times negative 14 is negative 14. What multiplies to make negative 14 and adds to make negative 5? Negative 7 and 2. So then I go ahead and I place them in the 4 boxes. And factor out greatest common factor from each row and column. I can take an x out here, a 2 there, an x out here, a negative 7 there. So when he's all factored, this problem turns into x minus 7, x plus 2. And then remember, we're trying to solve here. So factoring is a way for me to get my two solutions. This solution, x would be 7 if I set him equal to 0. And then this solution gets set equal to 0 as well. And then he becomes x equals negative 2. So I have two solutions here in this problem. Now notice a little caution symbol on the side. Remember this whole thing that I was doing with checking my solutions? We have a problem because one of these solutions may not work out in my original equation that I was given. So the only way for me to know is to actually check both solutions. So I'm going to start with the 7. If I plug a 7 into the original, it would look like 7 plus 1 equal sign, radical sign, 7 times 7 plus 15. So 7 plus 1 is 8. On this side, 49 plus 15. And if I go ahead and calculate what is 49 plus 15, that is 64. And then we would say, is this correct? Does this work out? Is 8 the same as the square root of 64? Yes. So 7 works. Okay, he is a good solution. Let's try negative 2. Negative 2 plus 1 equal sign, square root, 7 times negative 2 plus 15. Negative 2 plus 1 is negative 1. On the other side, we have square root, negative 14 plus 15. square root of 1, and the other side's negative 1. Is the square root of a 1 negative 1? Can you square root a number and get a negative answer? Well, this is the positive square root of 1. That's just 1. That's not good, okay? We got to be careful. That's not looking good. So negative 2, remember, is what we would call that extraneous solution. So he does not work. And we want to be careful for that. Okay, we want to be careful that we're looking for those solutions that do not check in there. The other one, I had 8 equals the square root of 64, which is positive 8. So yay, 8 equals 8, good times. But the other one, I did not get that to work out. So be checking, especially when you have those two solutions. Okay, so we're going to be working on solving equations that have radical signs in them. Thank you for taking good notes.